Welcome to the Deep Dive. Today we're diving into AI, specifically for you guys, K-12 public school principals here in Kansas. As part of the Kansas AI Literacy Initiative. With Landever AI, we know you're all really busy. So we've gone through tons of research, and we've zeroed in on the most impactful insights about large language models.
Right.
Or LLMs, no jargon here. Just practical knowledge to help you all navigate the AI world.
Exactly. We really want to give you a solid understanding of these powerful tools and explore how they can really enhance education support teachers and ultimately prepare your students for a future shaped by AI.
Okay, so let's unpack this. We're talking about AI that can write like a human, translate languages,
Yeah.
and even create different types of creative content. I've even heard some people calling these things supercharged brains.
Yeah, and what's really fascinating is that these LLMs are trained on an incredible amount of data. We're talking trillions of words. This vast amount of information allows them to learn patterns and relationships in language, enabling them to generate this incredibly human-like text.
So it's not just about throwing any data at these LLMs, right? It's got to be quality data.
You got it. And this is a key takeaway for you as principals. Think about how this applies to education. It's not just about the quantity of information we give our students, it's about the quality and how relevant that information is.
That makes perfect sense. Now, the articles that we read mentioned that these tech giants like Google, Meta, and Apple are all in on this whole LLM game. What's their approach and why are they so invested?
Well, these companies, they recognize the potential of LLMs across all these different sectors, including education. So they're pouring resources into research and development, really pushing the boundaries of what's possible with these models.
Let's talk about a specific example. One of the research papers focused on Alibaba's Qwen 2 model. They really emphasized the data quality over quantity in their training process.
Yes, Qwen 2 is a great example of how taking a strategic approach to data can significantly impact the effectiveness of an LLM. They even used previous versions of their own models to generate more training data, specifically focused on instruction response pairs.
So they're basically having AI teach AI.
In a way, yeah. And this method, along with their multi-stage training approach, highlights how innovative techniques are being used to improve the learning and performance of these models.
Okay, now all this talk about training stages, regular pre-training, long context training, annealing, it's getting a bit technical for me.
Yeah.
Can we just break it down to the essentials for our principals?
Absolutely. The core idea is that these LLMs, they're not just fed all the data at once. They're trained in stages, gradually increasing the complexity and length of the text they can process. Think of it like building a student's reading comprehension over time. You wouldn't expect a first grader to understand a complex novel, right?
Right. You gradually increase the challenges their comprehension skills develop. So how does this relate to the long context training mentioned in the Qwen 2 paper?
Long context training focuses on increasing the model's ability to understand and generate longer pieces of text. They started with a context length of 4,096 tokens and expanded it to a massive 32,768 tokens.
Okay, hold on, token. What's that exactly?
Think of a token as a fundamental unit of language that the LLM processes. It could be a word, a punctuation mark, or even part of a word. Imagine breaking down a sentence into its basic building blocks. That's essentially what tokens are.
So the longer the context, the more complex and nuanced the language the LLM can understand and generate.
Precisely. This is super crucial for tasks that require the model to consider lots of information, like rating a detailed report or analyzing a lengthy legal document.
Okay, I'm starting to get the importance of context length and how it relates to the capabilities of these LLMs.
Yeah.
What about other companies like Apple? What was their approach to developing their LLMs? I think they call them AFMs.
Apple, being Apple, took a very meticulous and privacy-focused approach to data selection. They actually respected the robots.txt files on websites, which are instructions that tell automated systems like web crawlers which pages they can and can't access.
So they're teaching their AI to be polite and respect boundaries.
Yeah, think of it as responsible AI development. They emphasized quality over quantity, selecting a smaller data set, but ensuring that it was highly relevant and well-filtered.
That makes sense. It aligns with their whole brand image, their focus on user privacy.
And similar to Alibaba, they also used a multi-stage approach to pre-training, but with an extra stage focused on context lengthening.
3 stages. So what was that third stage all about?
They combined real data and synthetic data, which is basically artificially generated data that mimics real data to train their model on incredibly long sequences of up to 32,768 tokens.
So both Apple and Alibaba focused on data quality. and use this multi-stage training with a focus on context lengthening. It sounds like a pretty good recipe for success in LLM development.
It's definitely a trend we're seeing. Now, another important ingredient that's gaining traction is something called knowledge distillation.
Okay, break that down for me. What's knowledge distillation in the context of LLMs?
Imagine you have a large, highly trained LLM, like a seasoned expert in a specific field. Knowledge distillation is the process of training a smaller, more efficient model, like an eager student to learn from that expert.
So it's like a mentorship program for LLMs.
Exactly. The smaller model benefits from the knowledge and experience of the larger one, gaining efficiency and performance without the overhead of a massive model.
That's a great analogy. And it seems like a very practical approach to making these LLMs more accessible and efficient.
Right.
Did any of the models we read about use this technique?
Yes, both Apple and Google used knowledge distillation in their LLM development. Apple used it to create their smaller on-device AFMs, while Google employed it in their Gemma 2 models.
Tell me more about Gemma 2. What was Google's focus with these models?
Google's researchers argue that even smaller LLMs are often undertrained. Instead of just increasing the size of the training data, they focused on maintaining data quality and used techniques like knowledge distillation to get the most out of their models.
So it's not always about bigger is better. Sometimes it's about being smarter with your training.
Precisely. They used their larger 27 billion parameter model as the teacher to train their smaller 2 billion and 9 billion parameter models.
Smart. Leveraging their expertise to create more efficient and accessible models. Okay, I'm seeing a pattern here. Data quality, multi-stage training, and knowledge distillation. Are those the keys to creating a successful LLM?
They're certainly crucial elements. Now let's talk about Meta's approach with Llama 3.1. They went big, releasing a model with a whopping 405 billion parameters.
Wow, that's massive. Did they use a similar approach to training?
They did. Their focus was on refining the pre-training and post-training processes rather than introducing architectural innovations. They really doubled down on the data training Llama 3 on a dataset of 15.6 trillion tokens.
It's an insane amount of data. How do they even manage that?
It takes a lot of computational power and resources, but Meta, being a leader in AI development, has the infrastructure to support such a massive undertaking.
Impressive. So what were some of the key takeaways from Llama 3.1's training process?
They emphasize data quality control, using both rule-based filtering and AI-powered classifiers to ensure they were training on the best possible data. And just like the other models we talked about, they implemented a 3-stage pre-training approach.
It seems like everyone's doing that.
Yeah.
What were the stages for Llama 3.1?
They started with standard pre-training on their massive dataset using an 8,000 token context window. Then they extended the context length to a whopping 128,000 tokens in the second stage. Finally, they utilized a technique called annealing.
Annealing. That sounds more like something you do in a science lab.
It does, but in this context, annealing refers to fine-tuning the model on a smaller, highly curated dataset to refine its performance for specific tasks. Think of it as the final polish after creating a masterpiece.
Interesting. So while they went big with data, they also focused on refining the model's performance through this annealing process.
Exactly. Now, unlike Apple and Google, Meta opted not to use knowledge distillation for Llama 3.1. Instead, they focused on scaling their training data and refining their pre-training and post-training processes.
So there's more than one way to bake an AI cake, so to speak.
Precisely. And for post-training, they used a combination of supervised fine-tuning rejection sampling and something called direct preference optimization, or DPO.
DPO, can you remind me what that is?
It's a technique for aligning the model's behavior with human preferences, making the output more helpful and aligned with our values. Think of it as a way to ensure that the AI is behaving in a way that's beneficial and safe.
That's crucial, especially when we think about the potential impact of these models on education.
Absolutely. Now, one more interesting technique they utilized is model averaging.
Model averaging. I don't believe we've covered that yet.
It involves combining the parameters of multiple models to create a final, more robust model. Imagine taking the best traits of multiple individuals and combining them to create a super team.
Yeah, I'm starting to get a little overwhelmed with all these technical terms. But it's incredibly fascinating to see how much goes into developing these LLMs. What are your overall thoughts on the different approaches we've discussed?
It's striking that there's no single recipe for creating a high-performing LLM. Each research team has its own unique approach.
So it's a blend of art and science.
Precisely. But there are definitely certain trends that are emerging. Multi-stage training data quality control and a focus on context lengthening seem to be key ingredients.
Okay, that's helpful to know.
Yeah.
And it's exciting to see how these models are constantly evolving and improving.
It is a dynamic field. Now, before we move on to the intricacies of post-training these LLMs, let's pause here and let our principals in Kansas absorb this information about pre-training. What are your initial thoughts? What stands out to you?
Yeah, let's take a moment to reflect. This is a lot to digest, but it's crucial to understand these foundational concepts before we dive deeper into the world of LLMs and their applications in education.
Welcome back, principals. I hope you all had a chance to kind of process all that information about pre-training. Now let's shift gears and explore the world of post-training. It's like taking those powerful LLMs that we talked about and refining them to perform specific tasks that are actually relevant to your schools.
Yes, this is where it gets really interesting for us in K-12 education. We have these powerful AI engines, but how do we actually use them to enhance learning and support our teachers?
That's a big question. One of the key techniques used in post-training is something called supervised fine-tuning, or SFT. Think of it like taking a student who's really excelled in general studies and giving them specialized training in a specific field, like science or the arts.
So we're taking a general-purpose LLM and tailoring it to do specific tasks that are relevant to our schools.
Exactly. For example, let's say you want to use an LLM to help students improve their writing. You could fine-tune it on a data set of high-quality essays, providing examples of different writing styles, grammar, and vocabulary.
That makes sense. The model learns from those high-quality examples and then can assist students in developing their writing. What about other tasks, like helping students with research or providing them with personalized feedback?
Absolutely. For research, you could fine-tune an LLM on a huge library of academic articles and research papers. This would allow the model to understand complex research concepts and then help students find reliable sources.
Wow. That could be a game changer for students who are struggling with research skills or those who need help navigating all that information available online.
Exactly. And for personalized feedback, you could fine-tune the LLM on a data set of student work and teacher feedback. The model could then analyze student writing, identify areas for improvement, and even suggest learning resources.
That's incredible. Imagine how much time teachers could save if they had an LLM that could provide insightful and targeted feedback to students.
Yeah, it could free up so much of their time,
Yeah.
allowing them to focus on more individualized instruction and interacting with their students. Now, in addition to SFT, there are other powerful techniques used in post-training, like reinforcement learning with human feedback, or RLHF.
RLHF, that rings a bell. Can you remind us what that's all about?
Imagine you have a student who has learned a lot, but they occasionally make mistakes or go off track. RLHF is like having a mentor who can provide guidance and feedback, helping them stay on course and refine their skills.
So we're essentially guiding the LLM to generate outputs that are more aligned with what humans prefer and expect.
Exactly. And this is done by having humans evaluate the model's output and provide feedback. This feedback is then used to train a reward model that learns to predict which outputs are more desirable.
Okay, so the reward model learns what good output looks like based on human feedback, and then what? How does that actually help the LLM improve?
Well, the reward model is then used to guide the LLM during training, essentially rewarding it for producing outputs that are aligned with human preferences.
So it's like a positive reinforcement system for the LLM, encouraging it to produce better and better outputs.
Exactly. And this is super important when we're thinking about using LLMs in education. We want to ensure that the models are generating outputs that are accurate, appropriate, and beneficial for student learning.
That's a crucial point. We can't just let these models run wild. We need to make sure they are aligned with our educational goals and values. Now, you also mentioned DPO, direct preference optimization, as a post-training technique. How does that work, and how is it different from RLHF?
DPO is a more direct approach to aligning LLMs with human preferences. Instead of training a separate reward model like an RLHF DPO, directly optimizes the model's parameters to generate outputs that are more likely to be preferred by humans.
So it's a more streamlined and efficient way to achieve the same goal.
Exactly. And it's been shown to be really effective in improving the quality and safety of LLM outputs.
That's great to hear. Now, earlier we talked about model averaging as a technique used in pre-training. Does it also play a role in post-training?
It can. Model averaging can be used in post-training to combine the strengths of multiple fine-tuned models, creating a final model that is even more robust and reliable.
So it's like having a team of specialists, each with their own expertise, working together to solve a complex problem.
That's a perfect analogy, and it's especially useful in sensitive areas like education, where we want to ensure that the AI models we're using are as accurate and unbiased as possible.
That makes sense. Now, one thing that's been on my mind throughout this whole discussion is the potential for bias in these LLMs. We've talked about data quality and aligning models with human values. But how can we as educators be sure that these models aren't perpetuating existing biases that could actually harm our students?
That's a really important question, and it's one that researchers and developers are actively working to address. One important step is to carefully select the data that these models are trained on, ensuring that it represents diverse perspectives and experiences.
So diversity in the training data is key to mitigating bias in the model's output.
Absolutely. And another important step is to involve diverse teams of researchers and developers in the creation and evaluation of these models.
That makes sense.
Yeah.
Having a variety of voices and perspectives involved throughout the process can help ensure that the models are being developed and used responsibly and ethically.
Exactly. And as educators, it's crucial that we are aware of the potential for bias and that we are actively working to mitigate it. This includes being critical consumers of AI, carefully evaluating the models we use, and being transparent with our students about the limitations of these technologies.
That's a powerful message. We need to be proactive and informed in our approach to AI in education. We can't just blindly trust the technology. We need to understand its potential and its limitations.
Precisely. And as we move forward with implementing AI in our schools, it's essential that we do so in a way that is thoughtful, equitable, and beneficial for all students.
Well said.
Yeah.
Now, I know we've been focusing on the technical aspects of post-training, but I'm eager to hear more about how these techniques can actually be applied to real-world educational settings. Can you give us some concrete examples?
Absolutely. Let's shift our focus to some specific examples of how post-trained LLMs can be used to really transform the learning experience for our students in Kansas and beyond.
All right, so let's talk about how these post-trained LLMs can actually make a difference in our schools. I'm particularly interested in this whole personalized learning thing. It's something we hear a lot about, but how can LLMs help us make that a reality?
Well, personalized learning is really where the power of LLM shines. Imagine a classroom where every single student has their own personalized learning path, tailored to their individual needs and pace. LLMs can help us make that happen.
That sounds incredible, but how would it actually work? I mean, I can't imagine having an LLM create a separate lesson plan for every single student in my school.
Right. Well, that's where intelligent tutoring systems come in. Think of them as like AI-powered tutors that can adapt to each student's learning style and their pace. These systems use LLMs to analyze student work, see where they're excelling or struggling, and then they can provide personalized feedback and instruction.
So it's like having an individualized tutor for every student, like 24/7.
Precisely. And because LLMs can process and understand language so well, they can give feedback that's way more nuanced and insightful than just your typical computer-based tutoring systems. They can even adjust the difficulty and content of learning materials in real time based on how the student is performing.
That's amazing. I can already see how this would be so helpful for students who need extra support, or even for those who are ready for more challenging material. But what about my teachers? They're already so busy. How can LLMs help them out?
LLMs can be a really valuable tool for teachers, especially when it comes to those time-consuming tasks like grading. Imagine an LLM that can grade essays, short answer questions, and even code, while also giving detailed feedback to students.
Now, that would be amazing for so many of my teachers. It would free up so much of their time so they could actually focus on individualized instruction and interacting with their students more.
Exactly. And it's not just grading. LLMs can also help with lesson planning, giving teachers access to a ton of resources like lesson plans, activities, assessments, all tailored to their specific subject and grade level.
Okay, I'm starting to see the potential here. LLMs can really help both students and teachers. But what about the bigger picture? How can we use them to prepare our students for a future where AI is everywhere?
Well, that's the key question, right? It's not enough for students to just be passive consumers of AI. They need to understand how this technology works, its potential, and its limitations.
So we need to actually teach our students about AI, not just use it to teach them other things.
Right. And LLMs can be really useful tools for AI education. Imagine using an LLM to create interactive simulations that teach students about things like machine learning, natural language processing, or computer vision.
So we could actually have LLMs teaching students about LLMs. That's kind of cool.
It is, and it's a great way to make AI less mysterious and empower students to become creators of this technology, not just consumers.
That's a really important message. We need to give our students the skills they'll need to thrive in this AI-driven world.
Absolutely. Now let's talk a little bit about multimodal AI, which combines different types of data. Like text, images, audio, and video LLMs are really important in this field.
I remember reading about multimodal AI. It sounds so futuristic. How could we actually use it in education?
Okay, well, imagine a history lesson where students not only read about ancient Rome, but they can also see 3D models of the Colosseum, hear gladiatorial chants, and even interact with a virtual tour guide, all powered by an LLM. That's the power of multimodal AI.
Wow, that sounds amazing. It's like bringing history to life.
Exactly. And it can go way beyond history. Think about students creating multimedia science projects where they collect data, analyze it using AI tools, and then present their findings using text, images, and video, all put together with the help of an LLM.
I'm officially blown away. These multimodal AI experiences could completely change how our students learn and engage with information.
And it's not just about engagement. Multimodal AI can also make learning more accessible for students with different needs and learning styles. Like, imagine an LLM that can translate text to speech for students who have trouble reading, or generate visual aids for those who are visual learners.
That's fantastic. It's all about creating a learning environment that works for every student and their unique strengths and needs. But before we get too carried away with all the amazing things we can do, I think it's important to talk about the elephant in the room. What about the cost? I mean, these AI technologies sound really expensive, and school budgets are already so tight.
That's a valid concern. But the cost of AI is actually going down pretty quickly. And there are lots of resources to help schools implement these technologies effectively. For example, Landever AI, our partner in the Kansas AI Literacy Initiative, offers a lot of support for educators who want to start using AI in their classrooms.
That's good to know. So cost doesn't have to be a barrier for schools that want to explore the potential of AI.
Right. And remember, we're really just at the beginning of what's possible with AI in education. As these technologies keep developing, we can expect to see even more innovative and affordable solutions.
This has been an incredible deep dive. We've covered a lot of ground, from the technical side of LLMs to how they can be used in K-12 education.
It really has.
And I hope this deep dive has given you a better understanding of AI and its potential in education.
Remember, AI is not something to be afraid of. It's a powerful tool that, when used responsibly, can transform how our students learn and set them up for success in a future that will be shaped by AI.
Well said.
Huh.
And as we wrap up, I want to leave you all with one final thought. The future of education is being shaped right now, and you all have the opportunity to be a part of it.
Absolutely. Don't be afraid to explore, experiment, and embrace all the possibilities.
Stay curious, stay engaged, and keep diving deep into this world of AI.